So in this short clip, I'll explain how to calculate percentiles by hand, and then at the end we will also do it in Excel. So let's say we have a variable, let's call it x, and we actually have here 11 observations of that variable. This is already ordered, okay, from smallest observation 13, largest 62. So we begin, and in the end, let's say in the end, what we're interested in is the 17th percentile, just as an example. We'll use that. So what you first think about is what are actually we call them exact percentiles. What we mean here is, let's call them exact piece. Basically these particular values here, what percentiles do they represent? Let's start, we always start with the second one. And let's have another column here, number of values smaller. So well, you can actually start with the first one. How many values do we have in the sample which are smaller than 13? 0. How many values do we have which are smaller than 19? 1, and so forth. Okay, here, for instance, 27. How many values are smaller than 27? 1, 2, 3, 4. All right, so that's just counting up. This number will be useful. Okay, and then 10. And how we calculate the exact percentiles is basically this number here. So this number divided by n minus 1. Okay, divided by n minus 1. So here divided by 10. That will be the exact percentile. So in this case, this is particularly easy because that means for 0, it will be basically 0 divided by 10. So that is the smallest value, the 0th percentile. Then here we have 1 over 10. That will be the 10th percentile, or 0.1, 0. And so forth. Here we have 2 over 10. That will be the 20th percentile, or we have 0.20. You could multiply with 100, but we can just leave it like this. And this will be, and so forth. Okay, I'll just complete that. And we can think of here we have 90. And here we have 100th percentile, or 1.00. These are the exact percentile. So you can see the 50th percentile we know is also the median. Therefore the median, or P50, is 34. So let's actually represent that graphically. What we do is we'll have a little graph. We have move that out a little bit smaller so my image isn't interfering here. We have x on the horizontal axis, and then here we have the percentiles. The smallest percentile we know is is 13. So x value of 13. That is the smallest percentile. And let's go to the largest value, 62. Let's actually quickly write down, so that may not all be nicely to scale. Okay, here a bit closer, a bit larger, 24, 27. And I'll just do dots here to indicate these values. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so let's do that in red. 13 is the 0th percentile. 62 is the 100th percentile, or 1.0. So we have that here. And then we have all the next values are all the next 10 percentiles. So we have 0.5, 0.2, 0.3, 0.4, 0.1, 6, 7, 8, 9, 10. So let's do that here. Let's do these dots here. This is what we will later call a cumulative, sort of a cumulative density function. Okay, and these values are actually pretty uniformly distributed, and therefore this function almost looks like a straight line. It doesn't have to look like a straight line. For normal distribution, for instance, it wouldn't look like a straight line, but here, because they're uniform, they almost look like a straight line. Right? These are the exact percentiles. So now what we are really after is the 17th percentile. So here we have 0.1, here we have 0.2, and what we want is the 17th percentile, which is somewhere here. Okay, where it says 0.17, and basically we'll sort of want to what did I missed? 19 was the 10th. Actually, I didn't draw that very nice. Okay, 19th was the 10th percentile. This is here, and then 20 was actually the 20th percentile. Okay, so and the 17th percentile somewhere in between here. So we already know it's got to be somewhere between 19 and 20. So what I'm now going to do is I'll just have a little, sort of, I'll zoom in to this section here. I'll do that up here. Okay, that's sort of a zoomed in section. We have our two points. We know that that point here is 19, and that is the 10th percentile, 0.1, and then we have 0.2, and that is the value of 20. Okay, that's over here, and then that is 20. So why do I draw this picture? Because the way how we now calculate the 17th percentile, which is somewhere here, is that we'll basically draw a straight line here, and then we will check which value do we have here. Okay, so and from now on we can basically solve that with using what we know about lines. So this section here is shown here. Okay, that's sort of an enlargement of this section. So how do we calculate that? We know that, here we go. Okay, we'll do it down here with green. We know the value is going to be larger than 19. So we're going to have 19 plus something, and that something will be some proportion of the distance between 19 and 20. So let's already do that. The distance between 19 and 20 is 20 minus 19. It could of course be different values, but in this case these are what the values are. Now how far do we have to go between 19 and 20? Well, because this is a straight line, basically exactly as far as we have to go from 0.1 to 0.17. So the proportion we have from here, this proportion, or this value proportional to that. This is how far we have to go. So how do we calculate that? Well, that is 0.17 minus 0.1 divided by the length of the red area here, 0.2 minus 0.1. So this green bit will always be smaller than the red bit. So this value here, this ratio, will be smaller than 1. And it will be close to 1 if that 17 is close to that next point, or closer to 0 if that 17 was closer to the previous exact percentile. So what do we get here? We get 19 plus, here we have 0.07 divided by 0.1 times 1, because 20 minus 19 is 1. Here we have 0.07 divided by 0.1, that is 0.7. So that will be 19 plus 0.7 times 1, that is 19.7. So that is the 17th percentile. So to recap, you first calculate the exact percentiles. We've done that here. Then you see between which two exact percentiles is the percentile we want, here 17. It's between these two, between 10 and 20. Okay, and then you need to figure out, okay, how close to 10 or even 20 is it? And depending on how close the 17 is to 10 or 20, the 10th or 20th percentile, that's how close our actual percentile will be to either 19 or 20. That's why we have this sort of straight line. Okay, that is the assumption behind that. In Excel, the different percentiles functions, we use the percentile.inc function. And let's do that. So let me just switch to Excel. Here are the same numbers. So go to any free cell. We type in percentile. We want percentile.inc. We highlight all the values. And we say we want the 17th percentile. And what we get is 19.7. Exactly the same value we calculated here.